Hello and welcome to yet another video in my series of Inventor Professional tutorials. So, you've probably watched the previous ones, but if you haven't, then you'll have to go back and watch those. Specifically the ones where I made a piston head, a piston top off, a piston bottom off, and a screw. These are going to be used directly in this video, so you cannot follow this video without having made those parts beforehand. So today we're going to actually make an assembly of this piston. We're going to be putting it together. So the first thing we're going to want to do is we're going to want to make a new part, just like we've done previously. So select New. However, this time we're not going to be making a single part. So instead of choosing standard millimeter, we're actually going to choose something that's called standard millimeter.iim. Once you click this, you'll see that it actually doesn't say that it's a part. Instead, it says that it's an assembly. You can see that using the icon down in the right corner. But this is the one we're going to use instead of the standard millimeter.ipt we've been using previously. So just select that and click Create. Now that we've loaded, you'll notice that most of the view looks identical to what we're used to. However, some parts are different. For example, the top bar is slightly different. We don't have to care about all of these things that are shown here, but we're gonna have to care about the one I'm indicating now. Place from Content Center, or rather, a bottom option of that. Place. So choose that now. Now, once you click Place, you're going to want to navigate to the folder where you saved the previous part of the piston. I'm currently doing this on my screen now. So there, my V8. So open that folder. Then open the piston folder. And what you're going to do is you're going to choose the first part we're going to place in the assembly. So we're going to choose piston top off. And you'll see that we're actually holding the part right now. We don't really need to do anything special with this, so just left click to place it down. You then right click and choose OK to stop placing parts. Now that we've done this, you'll see that we actually have the part in the model, or rather in the assembly. And what we're going to want to do is we're going to want to make sure that this part does not move from the center of the assembly. So we're going to right click it and we're going to choose an option called Grounded. Now what grounded does is it actually makes so that a part is stationary at all times in accordance to its own center, so to speak. To put it more simply, if you have multiple parts in an assembly and you ground one of them, then that part is not going to move in relation to the other parts. Other parts are going to move in relation to that one. I think you'll see what I mean when we start moving. The important thing here is that you cannot drag this object around anymore. Now, once we've done this, we can actually start placing the other parts we're going to need. So click Place again. This time, choose piston bottom off. And you'll see that it's not really in the correct direction. So what we're going to do is right click, and then you see a couple of menus where you can choose Rotate. These rotate in different directions, and depending on how you place the parts, you're going to want to rotate them differently. But rotate them until they look roughly the way I make them look here. You can play around with those rotate buttons quite a while. Then just place it somewhere along those lines. Now, because we see the model orthographically, the part doesn't really lie where we think it lies. But this is still close enough for our purposes. We just want to make sure that it's within easy grabbing range. Then we're going to place another part. This time we're going to place the piston head. And you'll see that this one isn't rotating correctly either. So rotate it until it looks like this. And place it somewhere in your view. Be sure to not place any of these parts inside other parts. And then choose piston screw. Rotate it until it's in the direction I'm indicating. So you're going to want to rotate it this way. Then you click once. And then without pressing OK in the right click menu, click again to place another one. So that we have 2 screws in total. You can then right click and press OK. we now have all the parts we need to start working on the assembly. Now, what we're going to do now is we're actually going to put these together. What we're going to use is we're going to use a tool called Constrain. Now, Constrain works by making certain parts lie in relation to each other according to a certain amount of rules that we can specify. So just click Constrain for now. Then you'll see that a small menu opens. This menu has many different buttons, but we're not going to care about all of these specific buttons. What we're going to care about is the two first of these. Mate, which is used when you place two solid objects together, like on faces, and angle, which is when you define an angle between two different objects. The other ones are used for more advanced applications, which we're not going to use right now. Now, ensure mate is selected, and you'll see that there are some other things you can select. You can choose mate and flush in the bottom modifier here. These are kind of opposite, so to speak. Flush ensures that two areas are next to each other but not facing each other, while mate ensures that two areas are facing each other. So make sure to select mate. Then you click on the surface that I indicate, and then you click on the surface that I indicate on the piston bottom half instead. And you'll now see that the two parts are sort of conjoined or attached to each other. This is actually exactly what we're looking for. But you'll see that they're not completely in line. That's what we're going to use the rest of the constraints for. Generally speaking, you always need 3 constraints minimum to ensure that two parts are locked in relation to each other, meaning that they cannot be moved in any way in relation to each other. So we're going to have to place 2 more. And what we're going to do is we're going to choose flush, since we want areas to be like next to each other but not facing each other. So what you want to do is you want to make sure flush is selected. Then you're going to click on the face that I indicate, and then the same face except on the piston top half. And you'll see that they now lie next to each other. And then we'll do the same for these 2 faces. You now see that it lies perfectly in line where it should be. Or at least, if you know how a piston looks, you'll know that it's exactly where it should be. But you cannot move it, and that's the important part here. You cannot move it in relation to the first part, which is exactly what we were looking for. Now we're just going to have to constrain the other part as well. So choose Constrain again. Make sure Mate is selected. And then Mate can actually do some other things more than just making 2 surfaces touch each other. It can also be used to make 2 center lines be shared. So as long as you have Mate selected, you can actually click the center of a circle and you'll get its center line. Now, if you actually constrain 2 center lines, meaning you constrain the center line of one circle to the center line of another, you can make sure that they share the same central axis. So first we're going to click on the piston heads circle, and then we're going to click on the top half of the pistons circle. And you'll see that they actually are now sharing a central line. So you can drag the piston head around, but it'll still stay like centered the way it should be. Now, pull it away a bit so we can actually work on this easier. Now, we have some remaining things to do. First, we're gonna need to set another constraint on this one, since we can pull it away from the part still. We're gonna choose Mate Constrain again, and this time we're gonna click on the inner circle of the piston head here, that I'm indicating, and the same one on the piston top half. We've now actually made all the constraints we needed. Now, I hear you saying, but didn't we need 3 constraints for this one? And you're partly right, but the way that this works is that we can now move it in a rotational direction, which is not something we need to worry about. This is going to fix itself once we actually insert it into an engine. So this is actually all the constraints we need, since we actually want it to move. Now we're just going to constrain the 2 screws, and then we should be finished. So first, choose Constrain. Then, constrain the center line of the screw to the center line of the screw hole. Do this for both screws. Then, still using mate, select the top piece of the screw and attach it into the sinkhole we made for the screw earlier. Now, it may look like the screw disappeared, but if you click apply and select the screw or just hover over it, you'll see that the screw is still there. It's just the same color as the piston itself. Because we've actually made it a sunken screw. It's completely inside the part. Now, we do the same thing for the other screw. Now we're practically finished. We just double check all our parts to make sure that they don't move in ways we don't want them. So first, we check the piston bottom half. And you'll see that it doesn't move. Then we check the screws. And here we see an issue. They move. Screws shouldn't move inside their sockets like that. That's a problem. So we're just going to Control Z that. And we're going to have to make another constraint. And this time, we're actually going to use the angle constraint. Now, this opens a menu with a lot of options that may seem jarring at first, but we're actually not going to work with most of these. Especially, we're not going to be using the explicit reference vector, which is selected as default for some reason. We're going to use something called directed angle. And what you'll see is that it removed the third selection option, because you don't actually need a reference vector. That's a much more complicated thing that we're not going to work with. So, what you're going to do with this one is you're just going to select the line indicated here on the screw. And then you're going to select a line which is in the direction you want the first line to point in on the main part, like this. And they will now be directed at a certain angle, meaning that the screw is now completely stuck the way we want it. Now, we're just going to do the same thing for the other screw. So, we're going to have to select constraint again, angle, directed angle, select a line on the screw, and select an appropriate line on the main part. And then just click apply. And now we should be finished with the part. We'll just double check everything again. Piston bottom half doesn't move. Good. The screws doesn't move. And the piston head only moves in the direction we want it to move. Meaning we've actually correctly assembled this entire piece. Now that's actually all we're gonna have to do this time. We're just gonna do one last thing. We're gonna choose save, and we're gonna save it in the piston folder, and we're gonna call it piston assembly. And press save. There we go! We are now actually completely finished with our piston. Now, the video series may continue and make a full V8 engine, but we're gonna have to see how that turns out. But as far as I'm concerned, I think that we have actually covered most of the basics you're gonna need to use Inventor Professional in a good, standard way. Of course, there are a lot of cool functions that I haven't talked about yet. For example, I haven't talked about the sweep function or the rectangular repeating pattern function, both which I use very often. But we're just not going to be able to fit that into this short video. So, I'm just going to have to bid you adieu for this time. And, well, good luck with your engine making.